Okay, hello everyone. Welcome to Apex Science Academy. Today we're going to solve the problem we posted as a problem of the week, our first weekly problem actually in 2024. And let's read the problem first. So suppose you take a cruise ship to travel from the Earth to the nearest solar system, Proxima Centauri. The speed of this cruise ship is about 20 kiloknots, or 20 nautical miles per hour. Each nautical mile is equal to 1822 meters, and the distance to Proxima Centauri is 4.2 light years, which means it takes light to travel 4.2 light years for the same distance. And we also know the speed of light, which is 3 times 10 to the power of 8 meter per second. Well, the question is how many days will it take for the cruise ship to reach the destiny? If you are and you're only required to show the order of magnitude by rounding your answer to the power of 10. And you're not going to be encouraged to use a calculator. So this is a very typical physics problem where you're going to be estimating the order of magnitude rather than giving a detailed decimal point results. Well, I want to say there are two common, I would say, traps or misunderstandings. The first one is plug in numbers as early as possible, so you get every single step you plug in numbers. And the second common or disencouraged practice in physics is to use actual numbers all the time. So on the contrary, in physics, we would like you to embrace symbols. Use symbols as much as possible and only plug in numbers, if possible, at the very last step. And here's what I'm going to give you an example of how we do this problem. The first thing is, when you look at the problem, you realize the bigger picture is just d distance equals to velocity times time, right? That's our basic physical principle here. And the question is asking you to solve for time, therefore equals to distance divided by the velocity. Well, of course, the distance and the velocity are none of them are given directly, so we need to find them each individually. For the distance, well, we know that it's the speed of light. Well, in physics, we always preserve c for speed of light. For some reason, we don't know who came it, probably from Einstein, but we're going to use c for speed of light. And it takes speed of light to travel 4.2 years. So we're going to say it's capital T that indicates how long it takes light to travel from the Earth to the destiny. And divided by velocity, right, of the cruise ship. So that's our bigger picture, right? So it's really a conversion of, because the speed of light is different from the speed of the cruise ship, therefore the light, it takes much longer for the cruise ship to travel to the destiny. Okay, so now we're going to start to plug in the numbers, but remember they have different units, so this is going to be really slow. And I don't want you, typically in algebra, you're going to multiply with conversion factors one at a time, but see what we're going to do in physics as a professional. Okay, so c is 3 times 10 to the power of 8 meter per second. Okay, and the time is 4.2 years, so it's going to be 4.2. Because we have seconds in our time unit, so I want to make everything as possible as seconds. So it's 4.2 years, and the year is 12 months, right? And each month is about 30 days, roughly speaking. And each day is about 24 hours. And each hour is 3,600 seconds. Okay, so that's our top equation. That's distance. When you multiply all of this together, you see the second on the denominator here will be cancelled from the second from numerator. So we end up getting a meter in our distance. Okay, so on the bottom, I would also like to convert everything into seconds, right? Or meter per second. So here we go. The speed of the cruise ship is 20 nautical miles per hour, and each nautical mile is 1822 meters per hour, right? So let's do the conversion one at a time. Okay, and so now I put in continuous form here. That's going to be 3 times 10 to the power of 8 meter times 4.2. Okay, now I'm going to use dot, but I can give you enough space so we don't miss it with decimal points. But this is a very common practice in algebra, I think. 12 times 30 times 24 times 3600. Okay. And we have cancelled out the seconds already, so we don't have to rewrite it. You see, the reason I don't use this symbol for multiplication is, well, you know, in algebra and in physics as well, we use x all the time. So to avoid any misrecognition from handwriting, I would just use dot, you know, a central dot to represent the multiplication. Okay. On the denominator, I'm going to use 20 times 1822 meter. I want everything to be in, well, I want everything to be in days, right? So I want this thing instead of hours. I want it to be days. Well, 1 hour is about 1/24 days. Okay, and that's it. So now we have everything in meter and in both the denominator and the numerator, and we also have the time unit to be in days. Okay, so now the remaining part is to try to collect all the numbers. You see, when we solve this problem, we didn't solve individual distance and velocity. We convert them into units. We put everything in symbol, and we put this very long, you know, fraction in both denominator and numerator, right? So this is a very common practice in physics. You plug in the numbers in the very last step, well, at least as late as possible. All right, from this moment, let's continue working on it. So I don't need to worry about the meter anymore because these 2 meter units will cancel out from the denominator and numerator. Okay, and this is going to be 20 times 1822 times 24, and in days, because we're dividing day, unit of day, and so that's when you divide it 1 over day, it becomes days. Okay, so now we're only estimating the order of magnitude, meaning we don't have to worry about all these. We're going to do a lot of approximations. It's very common in physics, and this is the trick I want to show you, because you don't want to necessarily need to know, you know, the exact numbers. It's just very quick as possible, right? Okay, so there are a couple of things we can do here. You see, I got a 18, 22, and 3600. Well, when I can, roughly speaking, I can cancel them out with divided by 1800, And 1800 is close enough to 1822, right? It only differ by about 1%. So I'm going to just cancel this. And so I'm going to make this into a 2. Okay. I have the 24 over here. I have another 24 over here. I can cancel them out. That's easy. And I have a 1020 over here. And this is a 360. So when I cancel them out, I get a 18, right? Okay. So everything cancels out. After we get everything canceled out, in the denominator I'm going to have a 1, and in the numerator I have 3 times 10 to the 8th times 4.2 times 18 times 2 days. Okay. Well, at this point, all right, we can go ahead. Now, the last step is really a wild card. You can go any different way. You can go to calculator, but I said we don't want to use calculator. So let's try to estimate as much as possible. Well, okay, I'm going to approximately say, I should use approximation as well as over here as well. It's going to be 3 times 10 to the power 8. When I multiply 2 with 4.2, it's 8.4, but it's close enough to a 10, right? Times 10. And 18, it's close enough to 20. Okay, so in total, this is going to be 6 times 10 to the power of 10th of days. I need to put the days over here. Right? And that's it, right? So the result will be 10 to the power of 10 days. That's how long it takes for the cruise ship to go from the Earth to our nearest solar system. Okay, all right, I hope you get this correct. Feel free to send us messages, especially you're a Apex student. We will have all the time for you to discuss different steps in the solution. All right, thank you, bye.